So, is AI actually making you a 10x developer? Or is it kind of just helping you generate a 10x mess at lightning speed? Think about it for a second. With the rise of these awesome agentic coding tools, we can literally spin up entire modules in minutes. But if you don't have a deep, fundamental grasp of system design, are these tools truly accelerating your output? Or are they just accelerating your technical debt by churning out a bunch of unmaintainable AI slot?
I mean, we've all been there, right? You look at a chaotic code base and think, who on earth wrote this garbage? It is practically a rite of passage for developers. Well, throughout this explainer today, we are unpacking the true nature of technical debt, looking at decades of engineering experience paired with the realities of building software in 2026. And our core thesis is incredibly simple, but honestly, it's powerful. True engineering mastery means treating technical debt not as a failure and definitely not as a lack of skill, but as a highly strategic business trade-off.
Okay, Section 1, Redefining Technical Debt. Let's look at the difference between bad code and actual debt.
See, we need to fundamentally reframe this, because there is a massive difference between bad code and technical debt. Bad code, that's just a mistake. It is totally unintentional. It usually stems from a skill gap or a completely broken process. And here's the kicker. Absolutely zero business value was gained by writing it poorly. Technical debt, on the other hand, is a rational, deliberate decision. It's a strategic shortcut. You are actively choosing to ship a suboptimal solution right now to capture immediate market value, maybe to test a hypothesis, with the explicit understanding that you are going to pay a higher cost to change it later. Remember Ward Cunningham's original metaphor for tech debt? It was all about shipping that first version so you could learn from your users, not about giving you an excuse to write sloppy code.
Right, moving on to Section 2, the seniority spectrum and developer evolution.
It's really fascinating to map out how a programmer's relationship with codebase friction matures as they progress in their career. Notice the progression here. You go from simply reacting to a codebase to strategically mastering and influencing it. When you're a junior, you're mostly just recognizing symptoms. When you hit the senior level, you start evaluating those downstream risks and actually owning the outcomes. And by the time you reach the staff level, you are literally multiplying your impact. You're co-owning the technical roadmap, you're pointing out the dangers that nobody else wants to say out loud, and you're driving these massive debt migrations to unblock multiple teams all at once.
Let's zoom in on that first stage for a second. As a junior, or honestly, anyone in their first 90 days on a new codebase, you really have to learn how to recognize visceral symptoms. You know what I'm talking about. It's that function signature that mysteriously grew a fourth Boolean flag, like skip cache or legacy rules, or that one file everyone tells you to route around saying, oh, don't put your code in there, use the new service. Your job at this stage is to ask constructive questions about why that strange pattern exists before you jump to defensively judging whoever wrote it, because usually there was a very real-world constraint that forced their hand. Now, as you level up to senior, your perspective completely shifts toward outcomes. Seniors focus heavily on downstream risks. They know this rule of thumb perfectly. A shortcut is only a legitimate engineering move if the trade-off is recorded and the outcomes are owned. Seniors understand that if a quick hack creates an architectural pattern that other developers start copying, you haven't just borrowed time. No, you have multiplied debt across the entire codebase. Next up, Section 3, playing the winner's game, but the focus on business cost.
So mastery isn't just about closing out tickets. It's about optimizing for real business outcomes. And the crucial shift here is how you communicate. Masters stop arguing about subjective concepts like clean code. If you just say this code is bad, you're basically just asking a tech lead to agree with your personal aesthetic taste. Instead, masters talk about objective business costs. Saying something like, working around this legacy module cost me 3 hours today completely transforms the conversation. It strategically pushes back against quick hacks by proving, definitively, that the technical debt is already hurting your delivery speed and costing the business money.
Section 4, sustainable disciplines and daily habits.
Okay, so how do we actually prevent this debt from piling up while we're rushing to meet deadlines? We need to ground this high-level strategy in reality by building small, sustainable habits that compound over time. These are fast-paced disciplines. You don't need a dedicated sprint or management approval for them. First up, the Boy Scout rule. Just leave the code a little better than you found it. Rename a confusing variable if you're already in the file anyway. Second, immediate testing. Write the test the exact minute you fix a bug, because I guarantee you that is the only time you will ever understand the failure perfectly. And third, please delete unreachable dead code. Stop leaving it there just in case we need it. Version control exists for a reason, folks. Get remembers it, you can let it go.
And this discipline extends right down to how we write our comments. Swapping out a useless, wishful to-do for an actionable, owner-driven note is an absolute game changer. A comment that just says, to do, clean this up, is basically just hiding work. But if you add an owner and a specific trigger, like replacing a function once the billing API ships, that ensures the work is actually being tracked and deferred the right way.
Section 5. The third day effect and adaptation to debt.
Let me ask you something. Why is it that developers inevitably stop seeing the massive debt piling up all around them? Why does a chaotic, terrible code base suddenly start to feel normal after a few months? Well, consider the timeline of adaptation. On day 1, fresh eyes spot absolutely all the friction. By day 3, you're pretty confused, but you're starting to learn the workarounds. By month 6, those workarounds are just muscle memory. The friction completely stops registering in your brain. And what this means is that the newest member on your team is actually your ultimate debt detector. A master developer actively goes to the new hire, asks them what confused them that week, and writes it down before they adapt to the mess.
Finally, Section 6, Mastery in the AI Era and Avoiding AI Slop.
Let's tie this entire evolutionary arc back to our original hook. What is the ultimate modern test for a professional developer in 2026? Look, AI is an incredible multiplier. It really is. But here is the hard truth. Without system design mastery, it just creates a 10x mess. AI tools can instantly generate boilerplate, they can implement features, they can suggest fixes, but if a human master isn't there guarding against architecture drift, reviewing the code for hidden security flaws, and closing testing gaps, the AI is just going to weave an incredibly complex web of technical debt. And ultimately, you, the human, are going to have to untangle and resolve that massive mess.
So, I want to leave you with a final, slightly provocative thought. Think about the code you shipped this week. Honestly, how much AI slop did you merge simply because it compiled and ran, without truly understanding its impact on your broader system design? Are you controlling your code base and strategically managing your technical debt, or is the AI controlling you? Thanks for diving into this explainer with us, and keep building with intention.